more to a fabulous edition of Coach Duhon's Geometry Notes. Today we're going to talk about similarity theorems for triangles. Okay, we've talked about this before. When we say similar, we mean similar figures have the same shape, but different, but not the same size. So same shape, different size. And so in similar figures, corresponding angles are congruent and sides are proportional. And then scale factor is the ratio of the corresponding sides, or side lengths. It depends on the order written. So scale factor for an enlargement we talked about is greater than 1. For a reduction is between 0 and 1. So depending on which one you consider to be the original and which one you consider to be the image will tell what the scale factor will be. Now when we talk about similarity statements, recall that we had congruent statements when we dealt with congruent triangles. We would say triangle ABC is congruent to triangle DEF. Well, now we also can do similarity statements. So we have 3 possibilities for similarity. We have angle-angle. So if any 2 angles of one triangle are congruent to 2 angles of another, then the triangles must be similar. Because think about it, if 2 are congruent, if I have a 100-degree angle and a 20-degree angle, the only other possibility would be 60 degrees. So the third one has to be congruent. That's why we don't have to say AAA, just AA is enough. Also, if we go with side, 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 if the length of the corresponding sides are proportional, all 3 sides, then the triangles are similar. And finally, we can do side-angle side similarity. So we have 2 sides in one triangle proportional to 2 sides in another, so they have to be proportional. And the included angle in both are congruent, then they're similar. So again, side-angle side is like I'm a little ant moving around the triangle. I can do side, angle, side, and then for the other one I have to do side, angle, side. I have to follow it around in order. Okay? Let's look at some examples. Example 1, determine if they're similar. If so, write the similarity statement. Now remember, the similarity statement has to be in order, so corresponding parts have to be congruent. Corresponding parts have to match up, sorry. So here we go. We've got a 44-degree angle. So if this angle is 44 and I have a right angle, that means this angle up here is 46. So now I've got a right angle, 44 and 46. This one has 47. So these are not similar. Okay. Looking at the second one, these marks tell us I've got a double arc here and a double arc here. So those are congruent. Single arc, single arc. Those are congruent triangles by AA. So, I mean similar triangles by AA. And my statement is, if I want to say ABC, triangle ABC, and that's the symbol for similar, it's just a squiggle, I have to write it in the same order. So angle A is congruent to angle D, so I have to call it angle D, triangle DEF is my similar triangle. Okay, you try example 2 and tell me if it works out. Pause the video and then come back. Welcome back. Let's see how we did. Now, we're given all the side lengths here, so we have to figure out, are the sides proportional? Okay, so let's see. I'm going to take I'm going to look at 6 over 15. That reduces down to 2 over 5. And then I'm going to look at, so that's PQ and TS. Now, the way these angles are drawn up, it looks like angle Q is going to would be congruent to angle T, right? So angle Q and angle S are not the congruent ones. So now I need to check, okay, are 5 and 12.5, does that follow the same ratio? Let's see. 5 and 12.5. 2 times 3 is 6. 5 times 3 is 15. So let's see. 2 times 2.5 is 5. And 5 times 2.5 is also 12.5. So, and you can do this on your handy dandy calculator. let's see if I can find my calculator app. And it's open. There it is. So kind of hard to see, but if I do 5, whoops, clear. 5 divided by 12.5, and I'm going to go math, enter, enter, and it tells me that it is 2 over 5. There it is. And so my third side, so this is PQ and TS. This is QR and RT. So now I'm going to have to evaluate PR and RS. So now I'm going to have 8 over 20. And let's see, 4 times 2 is 8, and 4 times 5 is 20. So that is that is PR and RS. So because they all follow the same proportion, these are similar by side, side, side. And my similarity statement, triangle, let's start at P. So I'm going to say P, Q, R, similar. So I know that if I start at P and then I go P, Q, R, well, QR is proportional to RT. So this triangle will be S, T, R. So I go PQ and ST, and then I go QR and TR. And then the last one would be RP and RS. So that's my similarity statement. It has to be written in order. All right, let's flip the page. Example 3, give it a shot and come back and tell me what you got. All right, welcome back. Are these similar? Okay. We know that these two angles have to be congruent because these are vertical angles. All right, so I've got A. Now I need to check, are the two sides on either side proportional? Well, then I have 10 over 20, which is equal to 1 over 2, and I have 11 over 22, which is also equal to 1 over 2. So because 10 over 20 equals 11 over 22, that's a true ratio, then I have side, side. So this is proportional by side angle side. And I can say triangle, and let's say we're going to start at the middle. We're going to say W, T, Z is similar to, I need to start at W. Now I did WT, the proportional side to that is WY, so this one is WYX. Example 4, give it a try on your own and let me know. Let's see. Welcome back. I've got 8 over 12. That reduces down to 4 times 2 is 8, 4 times 3 is 12. I've got 4 over 6, that's 2/3. And the other side, I've got 5 over 8, which is not equal to 2/3. So these are not similar. All right, definitely not similar. Example 5. We want to identify what the similar triangle is here, and then say, can we solve problems based on the similar triangle? So let's see. If I've got 51 and some congruent angle here, this is 51 up here, and this angle is congruent to that one. So that means that I can say triangle, if I start at the 51, Y, X, Z. So I start at the 51, I go to the congruent, and I end at the blank one. Let's do that over here again. I start at the 51, KJL. KJL. So because I start at 51, go to the congruent mark, and end at the blank one, start at the 51, congruent mark, blank one. So that means that I can now set up a proportion. I know that KJ over XY, because it starts at the 51, ends at the congruent. Starts at 51, ends at congruent, is going to be equal to KL over YZ. So I can say 4 over 5 is equal to X over 15. Let's cross multiply and solve. I'm going to get 60 equals 5X divided by 5. I'm going to get x equals 12. So there we go. Find x and y. Now here the hint is this angle is in common to both triangles. So I could say that triangle ABE is similar to triangle ACD. Right? These lines are parallel, so because these are parallel lines crossed by a transversal, I know that these two are corresponding angles, so they must be congruent. So then I've got similarity by angle. Okay, so I've got similar triangles here. Now, I want to find what is y. Well, let's see. I know that I can set up my equation. I'm going to go the same parts over same parts. Right? So this side y over 3, I have to find x and y. So y over 3 is going to be equal to, now this whole side over here, y plus 3 over the whole side over there of 5. Didn't give us a whole lot of room to work it out, so we're going to do the best we can. We're going to slide up here. I'm going to cross multiply. So I'm going up to here. Cross multiply, I get 5y equals 3 times all of y plus 3. So that gives me 5y equals 3y plus 3. So when I subtract, 3 times 3 is 9. Got to distribute. Minus 3y minus 3y. I get 2y equals 9. So y is equal to 9 over 2, or 4.5. So that's my y. So 4.5 over 3, and this is 7.5 over 5. Okay? So that makes sense. 4.5 is 1.5 times 3. 7.5 is 1.5 times 5. So I like that. Now to solve for x. I know that I can use x over 3 equals 35 over 5. So that's the parallel side over the top side, parallel side over top side. Cross multiply, 5x equals 3 times 35 is 105. So to divide that by 5, that's going to give me x is equal to 21. All right? So there's x and y. The key when I'm looking at this figure is to recognize that this angle is in common. Okay? I could also say, hey, you know what? These are parallel lines, so these two are corresponding. This is a different transversal, so those two are also corresponding. So I got congruent up here and congruent down here, which gives me congruent triangles. All right, then we talk about problems where we have to draw a picture. So here we go. We have a cell phone tower. We have cell phone tower, and cell phone towers look something like this, right? That's our cell phone tower. It casts a 100-foot shadow. So here's our shadow of our cell phone tower. That's 100 foot long. At the same time, we have a 4.5-foot post. This is just a post. Nothing you can do for a post. Near the tower casts a shadow of 3.33 feet. All right, so this is the shadow here. Now we've got the same sun. The same sun is shining on them both. So that means that the angle of the shadow, that when I connect the top of the shadow to the top of the figure, is going to give me congruent triangles. All right, there we go, by angle, or similar triangles. Okay, so what I don't know is the height of the tower. So because I know that I've got this post here that's 4.5 feet tall, I've measured the post, I've measured the shadow, and then the height and that. So that tells me that I need to work around it that way. So I'm always do like parts of the proportion. So I'm going to say h over 4.5 equals 100 over 3.33. I'm going to cross multiply here. This gives me 3.33h equals 450. So h is going to be 450 divided by 450 divided by 3.33, which is 130, basically 135, 135.14, but we're rounding. So that's the height of our post. All right, the post is a little bit taller than the shadow. The cell tower is a little bit taller than the shadow. All right, see if you can do example 7. Draw your figure and come back to me. All right, example 7. We have a woman, and this cute lady is 5 feet tall, and she is standing 10 feet. So she's 5 feet tall, and she's standing 10 feet from a light pole. All right, and the sun casts her shadow at 8 feet. A woman 5 foot tall is standing 10 feet from a light pole. The sun casts her shadow at 8 feet. What is the height of the pole? This is a poorly worded problem. Sun casts her shadow at it. She's standing 10 feet from the light pole. Let's suppose that the sun, that she's lined up right even with both of them, and that this is 8 feet right here. So that means, again, similar triangles. I've got the same angle, congruent here, so she's lined up with it. So that means that this is going to give me 5 over 8 equals h over 10. No, h over the whole thing, h over 18. So 18 times 5 is 90 equals 8h. So divide by 8. I'm going to get h equals 90 over 8, 45 over 4, which is simplest terms. 45 over 4, which is approximately equal to 11.45 divided by 4 is 11.25. It is exactly equal to 11.25 feet. So our light pole is 11.25 feet. It casts a shadow a total of 18 foot long. I think that's the way to read it. All right. So that's similar triangles and a few applications. I hope you have fun with it. If you have any questions,